Hello everyone. So we are down to the last topic of your inorganic chemistry, and that is on coordination compounds. Before that, I want you to congratulate yourself for reaching this far. By the way, this topic is very lengthy, kaya naman I cut it into two parts. So you will have CC 10.1 and CC 10.2. Bear with me kasi marami questions involving coordination compounds sa board exam. I will be sharing my screen for your reference. Ayan. This is the breakdown of the subtopics. We have 6. First ay yung chemistry of transition metals, followed by the formula writing and nomenclature. And then third ay yung structures of coordination complexes. Those 3 will make up CC 10.1. The last 3 topics will be covered sa CC 10.2. Without further ado, we will start. Ayan. I have here a copy of the periodic table of elements. But I want to give emphasis sa ating transition metals. Those shaded violet. Before we discuss transition metals, let us first look back what happens during bonding. In order to form a bond, di ba ang nangyayari ang valence electrons ng isolated atoms combine? For example, methane. The 4 valence electrons of carbon combine with the valence electrons of hydrogen to form covalent bond. Si sodium chloride naman, si sodium nagdodonate ng electron kay chloride ion in order for it to complete its octet. And that is ionic bonding. The transition metals do not behave or do not form bonds in the same manner. What happens is that transition metal forms coordinate covalent bond. If you are listening closely sa ating previous crash course vids, you will notice na na-mention ko na si coordinate covalent bond sa Lewis acid-base definition. If that is the case, it means we can look at the formation of coordination complexes as Lewis acid-base reactions. Wherein, ang magiging Lewis acid natin ay si transition metal and later makikita nyo kung sino yung Lewis base. That is why ang main character ng ating coordination compounds na topic ay si transition metals. Kaya it is only necessary for us to discuss them. In a UPAC definition, si transition metals ay any element whose atom has incomplete or partially filled D subshells, or can give rise to cations having incomplete D subshells. In short, sila lang yung nasa D block. Ayun, nawawala ang aking pointer. Ayun. Sila yung nasa D block. Remember that we have S block, P block, D block, and then F block. Meron din tayong tinatawag na post-transition metal atoms or metal ions at sila ay sina aluminum, gallium, indium, thallium, tin, lead, and then bismuth. So, ma-observe nyo din na pwede silang mag-form ng coordination complexes. I have here naman a tabulation ng different charges or oxidation states na pwedeng i-exhibit ng ating period 4 transition metal ions. So we have scandium, titanium, vanadium, etc. So pwede sila mag-exhibit ng different oxidation states. So yun yung unique sa kanila kasi pwede silang magkaroon ng iba-ibang oxidation states. Ang consequence nun, they form a variety of coordination complexes. Kasi hindi lang nag-i-stick sa isang ligand ang pwedeng kumabit sa kanila, but a variety of ligands. Also, kung mapapansin nyo, ang ating coordination complexes ay colored. So yung color na yun, nagde-depend sa charge ng metal ion at sa type and number of ligands na naka-attach. So let's start with copper. Si copper, siya lang yung nag-iisang pwedeng magkaroon ng +1 na oxidation state. So hindi siya mahirap tandaan kasi siya lang yung merong +1. +2 naman, everyone can have +2, +2 oxidation state except for scandium. +3, lahat din sila except cousin, copper and zinc. In order for you to memorize kung sino yung may +4 at +5, si PG man. Titanium, vanadium, manganese. And yung chromin, chromium, and manganese, sila lang yung may +6 and 7 respectively. As you can see, iba-iba yung shading ng ating oxidation state. That is to imply na yan yung color ng, usually, yan yung color ng coordination complexes nila kapag ganyan yung oxidation state nila. For example, si vanadium, red-violet siya kapag +2. So, si vanadium 3 plus naman, green, vanadium 4 plus, blue, vanadium 5 plus, yellow. As you can see, si copper na +2, di ba? Blue. If you use copper sulfate pentahydrate sa inyong thesis, you will notice it's blue color. Kasi naka-+2 dun si copper sulfate. So, very wide ang variety ng colors ng ating coordination complexes. Ito na yung sinasabi ko earlier that we can view the formation of coordination complexes as Lewis acid-base reactions. Wherein ang ating Lewis acid ay si metal ion. Okay, Lewis acid. So, ang Lewis base natin, itong kabila. Yung tinatawag na ligand. Okay. So, bakit naging Lewis acid si metal ion? Kasi meron siyang empty hybrid atomic orbital. Di ba sabi natin, Lewis acid are electron pair acceptors. So, this empty orbital here can accept a pair of electrons from a Lewis base, which is the ligand. Kasi si ligand natin, meron siyang lone pair sa kanyang hybrid atomic orbital. So, readily, madodonate nyo yun. By definition, Lewis base are electron pair donors. And the resulting compound ay tinatawag na adduct or complex. Ang bond na meron sila ay coordinate covalent or dative bond. Ayan. So, ito lang din yun. Colored lang. So, may tinatawag tayong primary valence at secondary valence ni metal. Pag sinabi natin primary valence, that is the oxidation state of the metal. So, it expresses the ability of the metal to form ionic compounds with oppositely charged ions. So, primary valence, oxidation state lang siya. Secondary valence, on the other hand, is the coordination number of the metal. So, it expresses the ability of the metal to bind to ligands. So, primary, oxidation state, secondary, coordination number. Example, what are the primary and secondary valence numbers of iron in this coordination compound? Mamaya na tayo mag-deal sa naming. Remember that primary valence is the oxidation state. Yung secondary valence ay yung coord number. Kung ganon, hahanapin natin yung oxidation state ni iron sa compound na to. So, si iron daw, ayan. Overall charge ay 2 minus. Alam natin na si oxygen ay merong -2 na oxidation state. So, -2 times 4 ay -8. So, ano ang kailangan nating i-add sa -8 to to have -2 overall charge. Diba? Plus 6. Therefore, ang primary valence ng iron complex na to ay 6. Ang kanyang secondary valence ay yung coordination number. Ibig sabihin, ilan yung nakakabit sa kanya. Diba? Merong 4 na oxygen. Si oxygen dito yung tinatawag na ligand. So, 6 and 4 are the primary and secondary valence numbers of iron, respectively. Let's proceed sa denticity ng ating ligand. When we say denticity, it is the number of times a ligand bonds to the metal atom or metal ion. So it is the number of times na pwedeng kumabit si ligand sa metal. Kasi there are ligands na merong lone pair sa hindi lang isa, hindi lang dalawa, kundi maraming atoms niya. So kung ganon, pwede siyang kumabit sa different sites na yun. For example, pag sinabi nating monodentate, ibig sabihin, isang beses lang siya pwede kumabit sa metal ion. Example nun ay yung mga anions natin at yung mga simple bases natin like ammonia. Dito, sa compound na to, sa coordination complex na to, isang beses lang kumabit si ammonia kay copper. And that is sa nitrogen. Si nitrogen dito, yung may lone pair, yun yung dinonate niya kay copper 2+. So, isang beses lang. How about kapag bidentate yung ligand? Pag sinabi natin bidentate, dalawang beses siyang kumabit sa ating metal ion. Example ay si ethylene diamine. In short, or yung abbreviation, EN, small en. So kung makikita nyo, ito yung isang ethylene diamine ligand. Dalawang beses siyang kumabit kasi meron siyang dalawang nitrogen atoms na may lone pairs na pwedeng i-donate kay cobalt 3+. Ayan. So in total, itong coordination compound, meron siyang tatlong ethylene diamine ligands. So 1, 2, and 3. What if there are greater than 2 ways or times na pwedeng kumabit si ligand? So ibig sabihin, meron siyang 3 or more na atoms na may lone pairs. Ang tawag sa kanya ay polydentate ligand. Example ay si EDTA or ethylene diamine tetraacetic acid. So this is ethylene diamine tetraacetic acid ligand. As you can see, 6 na beses siyang kumabit kay cobalt 3+. Hahanapin natin yung 6. So ito yung iuna, yung kumabit ay yung oxygen na may lone pair kay cobalt. Pangalawa, oxygen pa rin na may lone pair. Pangatlo at pang-apat, puro oxygen. Asan yung other 2? Kasi sabi natin, di ba, hexadentate siya. Yung other 2, nitrogen atoms na yung nag-donate ng lone pair kay cobalt 3+. So may 6 na beses siyang kumabit kay cobalt. Therefore, hexadentate. I hope clear yun. Next. Coordination number and geometry. So, ano yung relationship nila with each other? So, normally, ang coordination number natin ay nagre-range from 2 to 9. So, etong geometry ko to, nag-a-arise sa orbital overlap ng metal ion at ng ligands. And ligand-ligand repulsions. So, kaya tayo merong regular geometries na na-observe. So, ang pagtingin sa geometry, yung center usually nung shape, siya yung metal ion, siya yung metal center. At yung nasa corners, nasa gilid, corners or vertices nung shape na yun, yun yung ligands. For example, if the metal has a coordination number of 2, usually ang napo-form niyang complex ay linear in geometry. If 3 naman yung coordination number niya, ang napo-form niyang complex ay trigonal planar. If 4 ang coordination number niya, ang napo-form niya ay either tetrahedral or square planar. So parang same lang to sa discussion yun ng molecular geometry. Ang difference lang, we are talking about coordination complexes. Pag 5 ang coordination number ng metal ion, we can have a trigonal bipyramidal complex or a square pyramidal complex. Trigonal bipyramidal, Kasi, ayan, triangle yung nandito sa gitna. But, may dalawang pyramid sa top at bottom. So, trigonal bipyramidal. Square pyramidal naman kasi square yung base, but still, pyramid yung shape niya. Pag 6 ng coordination number, we have octahedral, alam niyo na yan, and trigonal prismatic. Pag 7, we can form pentagonal bipyramidal complexes. Pentagonal, kasi yung nasa gitna ay ang shape pentagon. Still bipyramidal, tulad ng trigonal bipyramidal natin. If 8 ang coordination number, we can form square antiprismatic or trigonal dodecahedral complexes. Ito yung square antiprismatic. Ito yung trigonal dodecahedral. And last, kapag 9 ang coordination number, we can form tricup trigonal prismatic. Para lang siyang parehas sa trigonal prismatic, only that may tatlo sa gitna. Ayun. Examples of common coordination compounds. Ito yung sinasabi natin kapag 2 yung coordination number, linear. Example nun ay si diamine silver. So, linear siya. Diba? Ito yung metal center sa gitna, opposing sides yung ligands na ammonia. 4 na coordination number, ang geometry, tetrahedral. Example ay si tetraamine zinc. 2 plus. So, tetrahedral. Corners ng tetrahedron yung amine ligands. Again, pag 4 yung coordination number, pwede rin square planar. We have tetraamine copper. Ayan, square planar. Pag 6 yung coordination number, we can form octahedral complexes. Example ay si hexa-aqua iron 3+. Ito yun. Okay? Hindi naman siya naiiba sa molecular geometry. Yun nga lang, we're talking about metal ions and ligands ng complexes. Now, let's proceed sa nomenclature ng ating coordination compounds. Several guidelines are followed in naming coordination complexes. But we have 4 categories to take into consideration. First ay yung name ng anionic ligands, followed by the name of the neutral ligands is present. And then third, we have to consider the ligand multiplicity, kung ilang ligands yung nandun. And then last ay yung name ng metal center. So ito yung tinatawag na coordination sphere. In this case, yung coordination sphere natin ay yung cation kasi may plus charge siya. And we have the anion outside the coordination sphere. Ito, example lang to. And then we have the ligands. In this case, si ammonia at si chloride ions yung ligands. And then we have the metal center, si cobalt, not copper. Cobalt to. And then yung coordination number no ating metal. So dito 6 kasi may 4 na ammonia, may 2 chloride ions. So iisa-isahin natin sila. Let's discuss first the name of the ligands. So here are some anionic monodentate ligands. So kapag ang ligand natin ay ending with IDE, example, bromide, chloride, fluoride, iodide, i-replace natin yun ng suffix O when naming a complex. So, bromide becomes bromo, chloride becomes fluoro, fluoride becomes fluoro, iodide becomes iodo. Clear? So, if ending with ITE or ite and 8 naman, i-replace natin yung suffix ng ito and ato. So, nitrite becomes nitro or nitrito, carbonate becomes carbonato, oxalate becomes oxalato. By the way, dalawa yung names ni nitrite ligand dito. It can either be nitro, or nitrito. So, pag nitro siya, ang kumabit sa kanya ay nitrogen. Pag nitrito siya, ang kinabitan ng metal ay oxygen. Okay? Pero not simultaneously ha. Isang beses lang. Monodentate lang din to si nitrite. Ayun. Ganon din si isothiocyanate. It can attach to the metal center via S or via N. Kapag via N, isothiocyanato siya. Kapag via S, thiocyanato siya. I hope clear yun. Next ay neutral ligands. Most neutral ligands retain their name with few exceptions. So, si water, instead na water, aqua. Kasi ang pangit naman pakinggan, di-water zinc, ganun. So, kaya nagiging aqua siya kapag ligand siya. Si ammonia, nagiging amine, hindi ito typographical error na double M, ganun talaga siya. Pag carbon monoxide, we name it carbonyl, nitrogen monoxide, nitrosyl, methylamine, retain, ethylene diamine, retain. Next ay yung ligand multiplicity. Kung ilan nung ligand na yun yung kumabi. So, prefixes are used for indicating the number of ligands. Greek prefixes to be specific. Sorry for the noise outside. So, kapag dalawa yung number of ligands mo, kunwari dalawang ammonia na ligand. So, ang ilalagay mong prefix ay diamine. Pag tatlo, tri. Pag apat, tetra. Pag lima, penta. Pag anim, hexa, and so on. How about polydentate ligands? Most polydentate ligands ay may prefix na sa pangalan nila. For example, ethylene diamine. So kapag di pa ang nilagay nating prefix sa kanila, kunwari dalawa ng ethylene diamine ng present, diethylene diamine, very confusing na. Therefore, ang ginagawa natin for polydentate ligands, ine-enclose natin sila sa parentheses, and then yung ina-add nating prefixes ay bis, tris, tetra, quis, for 2, 3, 4 numbers of ligands respectively. So kung dalawang ethylene diamine ang nasa complex, bis ethylene diamine. Pag tatlo, tris ethylene diamine. We also use abbreviations for ligands kasi most of them are lengthy in names. So for acetylacetonate, ACAC, benzene BC, ethylene diamine EN. Ito madalas niyo itong makikita. Lalo na si EDTA. Yung iba nga hindi na alam kung ano yung meaning ng EDTA. So tinatanggap na lang as EDTA. Glycine, gly, and so on. So andito sa kabila, methyl, ME, ethyl, EP, propyl, PR. I want you to differentiate between acetylacetonate, acetyl, and acetate. Magkakaiba sila ha. Si acetylacetonate, ACAC, si acetyl, capital A, small c, si acetate, ACO. So they are different from each other. Next ay yung naming ng ating metal sector. So, ito pala yung una niyong titignan. Is the metal involved in the cation coordination sphere or in the anionic coordination sphere? Kasi kapag cation siya, pag part siya ng cation, ang ini-name nyo, manganese, molybdenum, aluminum, chromium, as is yung names nila. Pero kapag they are part of anionic complexes, you will place a suffix ate or ate. So manganese becomes manganate, molybdenum becomes molybdate, aluminum becomes aluminate, chromium, chromate, cobalt, cobaltate, tungsten. So usually naman, si silver, kapag part siya ng anionic complexes, yung iba nating metals, nire-retain yung kanilang Latin or kung ano man yung origin ng name. For example, silver, hindi silverate. So argentate. Plumate naman for lead. So si tin, tannate, copper, cuprate. Yun. So meron din tayong dalawang types ng nomenclature, the stock system and the Ewing-Bassett system. So this is what happened for, ayan. So sa stock system, ang ginagawa natin, we place the oxidation state of the metal in Roman numeral after the name of the metal itself. Again, yung oxidation state ni metal, nilalagay natin sa parenthesis in Roman numerals ha, after the name of the metal. So, sulat ko nga para hindi nyo makalimutan. So, dito ang charge ay yung nasa parenthesis ay oxidation number ni metal. In Roman numeral. Sa Ewing basket system, ang nilalagay natin ay yung charge of the coordination sphere. Coord sphere. Ito, hindi na to naka-Roman numerals. So, tignan natin yung oxidation state ni cobalt sa complex na to. Remember that water is a neutral ligand. So, 0 yung oxidation state niya. Si iodine naman, -1. Pero may 3, kaya -3 to. Therefore, ang cation na complex natin or coordination sphere, +3. So, ano yung cobalt? +3 din. Siya lang yung nag-contribute sa charge ng coordination sphere. Kaya dito, hexa-aqua cobalt 3. This is the oxidation number of the metal, cobalt, iodide. Don't forget to name the anion outside the coordination sphere. So, yung sa Ewing basket system naman, hexa-aqua cobalt pa rin. But, 3+. Yun yung charge ng coordination sphere. Ito, iodide. So, take note of that. Let's have some sample problems. So, name the following coordination compounds. Sige nga, yung una. Sige, start tayo. So, ito, walang. So, itong first, wala siyang anion. Cation lang siya, as you can see, +3. So, yan yung charge ng coordination sphere. Si amine ay neutral ligand. Si chromium, therefore, ay +3. So, ang name nito ay hexaamine chromium 3. Using the stock system. So, hexaamine chromium 3. How about, sige na nga, i-flash ko na. How about the next? So, ito, cation din, as you can see, kasi +2. So, both ammonia and water ligands ay neutral. Therefore, ang charge ni cobalt ay +2. Kapag may 2 types or more pala ng ligands, arrange them in alphabetical order. Without considering the prefix. Kasi yung iba, diamine, tetra-aqua. So, yung titignan yung D at yung T. Dapat yung name ng ligand. So, mauuna si diamine, AM. Followed by tetra-aqua, kasi AQ. Cobalt, 2. Next. So, we have a cation, si potassium, at anion yung coordination sphere natin. So, titignan natin yung oxidation state. So, si potassium, alam natin +1 to. Pero since may 3, magiging +3 yung cation. So, therefore, dapat -3 yung buong anionic coordination sphere, yung complex na to, na nasa bracket. So, in order for it to be -3, titignan natin kung ano yung oxidation state ni ion. So, si cyanide, alam nating -1 to, pero may 6, kaya magiging -6. So, ano ang kailangan nating i-add sa -6 para maging -3? +3. Kaya, ang pangalan niya, name the cation first, potassium, followed by the name of the anionic complex. Hexacyano, dahil may 6 na cyanide ligands, ferrite, kasi si iron ay part ng anionic complex. And don't forget the oxidation state of the metal, 3. Last. Ito, neutral yung overall charge. So, anong tawag sa ligand na to? May methyl, may amine. So, methylamine. And we have 2 chloride ions as ligands. Therefore, dichloro-base methylamine copper. So, part lang siya ng isang coordination sphere. Wala siyang anion. Kaya si copper ay named as copper. Otherwise, kung anionic siya, cuprate dapat. I hope clear yun. Next, give the formulas for the following complexes. So, amine trichloroplatinate and aqua tricarbonyl platinum. Excuse me. So, tignan muna natin yung name ng metal. So, dito sa una, platinate. Again, pag may suffix na ATE, anionic siya. Pag na-retain yung name ng metal, part siya ng cation. So, sa letter A muna tayo. Platinate, so that is platinum. So, ano daw yung ligand? Amine. Since walang prefix, isa lang siya. Trichloro. Platinate daw. So, titignan natin yung charge ng buong sphere. So, si ammonia natin, di ba, neutral to. Si chloride ion, negative 1. So, times 3, negative 3. Ang charge daw ni platinum ay plus 2. So, plus 2, 2 plus negative 3 ay negative 1. Kaya, ayan na yung ating formula. For letter B naman, still platinum. As you can see, anionic nga yung coordination sphere natin for letter A. For letter B, dapat cation yung makita natin. So we have platinum daw and aqua, isa lang, kasi walang prefix, tricarbonyl. So tatlong carbonyl. Ayan yung cation. And then we have bromide. Before that, hindi pa to yung final, titignan natin yung oxidation state or charges ng sphere. So, platinum ay plus 2. Si water at si carbonyl, neutral. So, therefore, ang charge ng ating coordination sphere ay plus 2. Ito, plus 2 to. So, kung ganon, ano dapat yung subscript ni bromide ion natin? Dapat meron dito dalawa. Para negative 2. Okay? Kasi plus 2 minus 2. I hope clear yun. Now, proceed tayo sa isomerism in coordination complexes. So, yung isomers natin, they have the same number of atoms. Nagkakaiba lang sila sa either sa connectivity or sa three-dimensional arrangement. So we have structural and stereoisomers. So pag structural, nagkakaiba sila sa connectivity ng atoms. Pag stereoisomer, sa 3D arrangement, sa space. So for structural isomerism, we have 5. We have ionization, hydration, coordination, linkage, and polymerization iceberg. For stereoisomers, we have 2, the geometrical isomers and the optical isomers. We will look them into detail. First ay yung ionization isomers. So si ionization isomers natin, nagre-result lang siya from the interchange ng ligands within the coordination sphere and outside the coordination sphere. So nagkakaroon lang ng interchange ng ligands at ions sa loob at labas ng coordination sphere. So for example, si bromine ligand, pagpapalit sila ni sulfate sa labas. So, si sulfate na ngayon yung nasa loob, si bromine na yung nasa labas. As you can see, simple interchange of ions or ligands, nagkaroon na ng change sa property. So, yung unang compound ay violet in color, yung pangalawa ay red. Next, hydration isomers. Kanina, ang pinagpalit natin, ions, within and outside the coordination sphere. Ngayon, ang pagpapalitin natin, water. So, kung may water sa labas, palitan mo yung isang ligand sa loob, isang hydration isomer na yun. For example, this chloride ion ligand, ipagpalit natin siya with water sa labas ng coordination sphere. So, hinhydrate natin at yung Cl nandun na sa labas. Di ba initially may 2 Cl? So, dinagdagan natin ng isa, so kaya 3 Cl. Kaya tinawag na hydration isomer kasi we are dealing with water. As you can see, magkakaiba naman sila ng property. The first one is blue-green, the second one is violet in color. There are other properties na pwede silang magkaiba. Pero para sa atin, mas madaling intindihin, kung nagkaiba sila sa kulay, automatic magkaiba na silang compounds. So next, coordination isomers. So si coordination isomers naman, nangyayari lang siya for those salts kung saan ang cations at anions ay parehas complexes. As you can see, yung una natin, ito, at itong anion natin, the cation and the anions are both complexes. Hindi siya pwedeng mangyari kung saan si cation lang yung complex. Dapat parehas sila. Kasi ang mangyayari dito, magkakaroon ng interchange sa ligands between the two metal centers. As you can see, nung una, si cobalt natin yung may amine ligands. Pero after the interchange, si chromium na natin yung may amine ligands. Yung initially, si chromium yung may cyanide ligand. Yung pangalawa, meron ng cyanide ligand si cobalt. So, ito yung tinatawag na coordination isomers. There is an interchange sa ligands between the two metal centers. Next ay linkage isomers. So, linkage isomers result when the ligand can bind to the metal center into two different ways. Again, si linkage isomers, nangyayari lang siya kapag si ligand ay pwedeng kumabit sa metal into two or more ways. Ang example nito ay si nitrite na ligand. So si nitrite, di ba nakita natin pwede siyang nitro or nitrito. So ito yun. Sa una, kumabit siya sa cobalt via oxygen. Sa pangalawa, kumabit siya sa cobalt via nitrogen. Still, magkaiba na sila ng property. So, ayan. Ito lang yung visual representation. So, itong kumabit sa O, color red. Yung kumabit sa N, yellowish. Next ay polymerization isomers. They are just isomers na same ang empirical formula, ibig sabihin yung simplest formula, but differs in molecular formula. In turn, pati molecular mass, magkaiba sila. For example, yung una, meron tayong isang platinum, dalawang chloride ion, tapos dalawang amine ligands. Sa pangalawa, instead of dalawang amine ligands, may apat, dalawa na din yung metal, apat na yung chloride ion. So, dinoble. So, in turn, magkaiba na sila ng molecular formula. Ibig sabihin, yung formula ng molecule. So, ayan. Ito, H6PtCl2N2. Yung pangalawa, lahat na yon times 2. Pero kung i-simplify mo to, ang kanyang empirical formula ay same dito sa left. Pero, magkaiba na sila ng properties. Next ay yung geometric isomers na tinatawag. Nasa stereoisomerism na tayo, meaning nagkakaiba na ng arrangement ng atoms sa space. So, hindi na to bago sa atin kasi pag sinabi natin geometric isomers, di ba? Sila yung cis at trans. From the Latin name cis at trans, cis meaning this side of, trans, the other side of something. So, kapag cis, yung ligands, yung two types of ligands or yung two identical ligands rather, ay nasa same side or nasa same phase, closest to each other. For example, ito, si ethylene diamine, magkalapit sila sa isa't isa. Kung magdodraw ako ng phase dito, ayan, ito yung phase, isang phase ng octahedron. They are lying on the same phase, yung ethylene diamine ligands. Kapag trans naman, they are on opposing sides. Magkalayo. They are furthest away from each other as possible. So, yun yung trans. Kung makikita nyo, magkaiba sila ng maximum or absorbance values. Again, kapag cis and trans, we are dealing with two identical ligands, yung positioning nun. Meron din tayong tinatawag na FACMR isomerism. Kanina, sa cis-trans, dalawa. Dito, we are dealing with three identical ligands, yung positioning nila. If they are found on the same phase, ayan, ito. Still octahedral yung geometry. Ayan, nasa same phase yung chloride ligand. Ito yung facial or FAC isomer. Kapag meridional or meridian, yun yung mer. Kung makikita nyo, along the meridian yung chloride ions. Andito yung isa. So, ito yung mer isomer. By the way, cis at trans pala, possible lang siya for square planar and octahedral na complexes. Tingin tayo ng examples. So, draw geometrical isomers of the following compounds. Sige nga. Titignan muna natin yung ligands na nakakabit. So, we have, for the first one, for letter A, we have two water ligands, neutral to, and I hope you can name this ligand. This is oxalato from oxalate. And ang metal center natin ay si manganese. First, baka akalain nyo na 4 ang coordination number ni manganese kasi may dalawang oxalate, may dalawang water. But, I hope this is not surprising for most of you. Bidentate si oxalate. Kasi meron siyang dalawang oxygen atoms na pwedeng mag-donate kay manganese. So, si oxalate natin, ganito yung itsura niya. I am not drawing the lone pairs anymore. Ayan. Ayan. So, etong oxygen na to, na negative, may lone pair silang pwedeng i-donate kay manganese. That makes them bidentate. Kung bidentate siya, dalawang beses siyang pwedeng kumabit sa ating manganese. So, 2 times 2 ay 4. Diba? 4. So, 4 plus 2, kasi dalawang water, 6 yung coordination number ng ating manganese. So, kung gano'n, ano yung mag-form niyang geometry? Sabi natin kanina, octahedral. So, dapat ang ma-draw natin for letter A ay octahedral. Ganon din for letter B. Kasi as you can see, may 6 siya. Parehas naman itong monodentate. So, in the next slide, I will show you the isomers of these two compounds. Okay? Simula muna tayo sa FACMR isomer ng letter B. Bakit FACMR? May tatlo siyang amine ligands, may tatlo siyang chloride ligands. Sabi natin, kapag yung tatlong identical ligands ay nasa same phase, FAC isomer yun. Kapag nasa meridian, mer isomer. So, si amine dito, nasa same phase ng octahedron. Pwede rin natin siyang tignan in terms of the chloride ligand. So, dito sa kabila, nasa meridian. Okay? So, that is the FACMR isomer. Next ay yung cis-trans isomer ng letter A. So, bakit cis-trans lang ang meron siya? Kasi, we are dealing with two identical ligands. So, for example, we have two identical oxalate ligands. Ito. So, nasa same phase. Diba? Closest to each other yung oxalate ligands. May water din. Pwede nating tignan. Ayan. Okay? Yung trans naman, they are on opposing sides. Ayan o. Magka-salungat sila. But, yung cis isomer natin, nag-arise pa siya sa another enantiomer. Pag sinabi natin enantiomer, non-superimposable mirror images of each other. So, itong cis isomer natin na una, kapag naglagay tayo ng mirror dito at nireflect natin yung ating cis isomer, ito ito na yung ma-form nating enantiomer. Non-superimposable mirror images of each other. I hope hindi nyo first time marinig ang enantiomer kasi binabanggit yun sa organic chemistry. Ayan. And dahil nga nasa enantiomers na tayo, next natin ay yung optical isomers. Pag sinabi natin optical isomers, nagkakaiba lang sila sa handedness ng complex. We have the lambda and the delta isomers. So ito, kung titignan natin, yung handedness niya to the left. Ayan o. Two of its ligands ay the left. So para siyang propeller twist. So ayan, nasa left. Kaya ang tawag sa kanya ay lambda. So kapag left-handed yung coordination compound, lambda isomer siya. Kapag right-handed yung ating coordination compound like this one, delta isomer siya. So nagkakaiba sila sa rotation or sa direction ng rotation ng plane polarized light. So yung delta, clockwise yung rotation ng plane polarized light. Yung lambda, negative or counterclockwise. I hope clear yon. So, see you on the part 2 of coordination compounds.